Hello everyone, my name is Zachary Helgert. I'm a sophomore majoring in nuclear engineering at UW-Madison, and I'll be talking to you today about two possible solutions to the long-term nuclear waste storage problem affecting our world today and tomorrow. The three main points I want to cover are as follows. First, why is long-term nuclear waste storage a problem? What ethical concerns are there related to this engineering issue? And what does this have to do with the near and far future? Secondly, we will be diving into the proposed solutions to this problem. This includes theoretical outlooks and real-world progress while dealing with the pros and cons of either solution. Lastly, we will conclude with deciding which of the two proposed solutions is the most practical and ethical. Then talking a little bit about the next steps involved with the long road ahead involving nuclear waste for the years to come. Currently, in the United States, there are 90,000 metric tons of dangerous radioactive waste scattered throughout the country, according to the U.S. Government Accountability Office. All of this waste requires proper disposal to ensure environmental safety for years to come. There is no long-term storage plan in place for this waste. This has many ethical concerns for the future. Specifically, future generations will have to deal with this waste. It is our responsibility not only to prepare them to deal with it, but also to plan for them not being able to deal with it. Engineers today working on storing this waste will have to assume that there could be a future where no one is around to maintain this waste. A societal collapse could occur due to many factors, but what is important is ensuring that future generations of people and animals don't have to live with the prospect of having dangerous radioactive particles in their water or air. Expanding off of that, obviously, there is an environmental concern regarding a large amount of waste with no immediate storage plans for the future. Without direct supervision and maintenance, the waste currently being stored across the country could be fatal to the ecology around it. Moving on to our first proposed solution, we have the idea of storing the waste above ground indefinitely. This is the current method of storage for almost the entire country. The process involves initial cooling in water baths at nuclear power plants after fuel has been depleted and is now unusable. Cooling can take around 5 years until radioactivity levels are low enough to not cause such large temperatures in the fuel. After cooling, the fuel is stored in large dry casks, which are essentially giant concrete cylinders. Concrete is used for its effective resistance to radiation penetrating through it, protecting the environment around it. The idea here is that if the entire country already uses this method without hiccup, then there shouldn't be a reason not to continue its use. Though instead of storing the waste where it was created, as it is now, in upwards of 50 locations across the country, it would be consolidated at a couple locations in order to reduce cost and ensure proper inspection. Now, I would like to discuss the pros and cons of the proposed above-ground storage solution. Starting with the pros. The above-ground storage solution has a large capacity. According to key issues associated with interim storage of used nuclear fuel, a study by Kadok and Yost, apologize if I pronounced that wrong, a large-scale model of the solution could house up to 40,000 metric tons of nuclear waste safely. This is about half of the amount of waste present in the U.S. today in one facility. According to the same study, this facility would need about $4 million a year in order to effectively and safely operate. It doesn't seem cheap as of right now, but once we relate this cost to the other proposed solution, it is drastically more cost effective. Finally, the facility is easily maintained. With a large concrete cask out in full view, possible structural fatigue and failure is easily spottable. Inspections of the waste storage will be often and thorough, allowing for little leaking. Also, if waste can be repurposed or reused in the future, there's little problem reaching the waste as it is out in the open. Now, we will move on to the cons of this method. Its pro is also its con. The above ground solution needs to be constantly maintained due to it being out in the elements and, if a leak should appear, allowing the elements to carry away dangerous radioactive particles into the environment. This is especially troublesome for future generations if, for some reason, no one is able to maintain the integrity of this storage method. As stated before, there's an obvious environmental risk involved with long-term storage out where leaking is possible. This very obvious downfall can and will affect its political weight as an idea to be practically implemented. Finally, there is a very real threat of purposeful leaks. Outside forces who wish to cause harm may find ways to exploit this large facility full of toxic waste. The dry casks were designed to withstand large amounts of impact, stress, and wear, but the threat itself is enough to, again, like the last con, affect how this method could be argued for politically and then practically implemented. I would now like to discuss the below-ground storage solution. This solution has one project in development currently in Finland called the Onkalo Spent Nuclear Fuel Repository. Due to this fact, everything about this solution will be centered around the engineering decisions of this facility. As in Onkalo, 1,400 feet below the surface is where the waste is stored. A location of low seismic activity is chosen as to not disturb the long-term waste for the many years it must remain underground. The distance below the surface is chosen for the hard bedrock that the waste will be encased in, but also to reduce the chance of people stumbling across it in the future. The waste is wrapped in a strong steel and copper container and is then placed in a cylindrical hole. As seen in the picture, the yellow railing indicates a location of burial in the bedrock. Finally, once a section of the underground facility is full, the remaining dugout sections are completely filled with clay. This reduces the ability of water to permeate through the bedrock and risk corroding the container and eventually leaking fuel. Now, I would like to discuss the pros and cons of the proposed below-ground storage solution. Starting with the pros. There is a low environmental risk with this method. Being so far underground and so tightly sealed, the likelihood of leakage into any water systems or outside in general is extremely low. If leakage does occur, it will likely have little to no effect on those above or near the storage facility. The waste is essentially encapsulated forever. This method is designed to last on its own for thousands of years. Due to this fact, it is very ethical in that it doesn't place the responsibility of dealing with or living with this waste on future generations. The waste is secured and should theoretically never have to be worried about. Lastly, the method is ongoing. Once the facility is created, it can be used for many years to store waste as reactors continue to create more power. The Onkalo facility is planning on being in use to store 5 reactors' full lifetime waste over the next century, according to the World Nuclear Association's report on nuclear power in Finland, meaning that the waste for the next 100 years in Finland is more or less accounted for, which is incredible as no other country can say the same. Now, I'd like to move on to the cons of this method. The below-ground storage method is extremely expensive. For storing 5 reactors worth of fuel from their full lifetime, it will cost a total of $4 billion over the next century, according to the World Nuclear Association's report on nuclear power in Finland. To contrast that, using the above-ground method for half of the United States radioactive waste over the next century will cost only 2/3 of what Finland is projecting. The United States has around 60 power plants. The below-ground method would be astronomically more expensive than the above-ground method. The waste is also inaccessible. If a major leak for whatever reason happened and it was causing real problems, it would be extremely hard to not only get to the waste but to also locate what specifically is leaking. On top of this, if one wanted to repurpose waste, it would be almost impossible to retrieve and use. Lastly, specific qualities are necessary in choosing a location for this method. On top of needing a public approval in the area, there must be a large amount of quality bedrock and low seismic activity in order to safely store waste. This can take decades of research in order to determine a feasible location. To conclude, it is safe to say that the underground method for all intensive purposes is the best choice for long-term storage of nuclear waste. There are 3 main reasons for this conclusion. It is ethically the most sound of the 2. In order to look towards the future with the best intentions in mind, the responsibility should not be placed on our children's children's children. We should, right now, be preparing for a future where this waste must be kept safe without maintenance and without any further thought after final storage. Environmentally, it makes the most sense. This method is the least likely of the 2 to cause any major damage to anyone outside of its containment. Due to its distance from the surface and the rigidity of its engineering, there should not be any major reason to fear an ecological disaster resulting from this method. Finally, it is the most realistic. This method is actually being put into practice right now at Onkalo. The structure in the figure to the left on screen is right now being built and will store nuclear waste for thousands of years. This method has been scientifically and politically backed. The world should follow in Finland's footsteps. Lastly, I would like to quickly go over what the next step should be for the federal government and governments abroad. First, reevaluate current plans. This method is worth consideration and should be put into practice wherever nuclear power plants exist. Second, create a committee to research locations within your country that could be potential candidates for this method. It has to be done eventually, and postponing it now is not a solution for future generations. Lastly, reach out to the power companies running the nuclear power plants in your country. Be vocal about what needs to be done and have an honest conversation about the necessity of this method. Go into details about finance as well. Progress needs to be made on storing nuclear waste all around the world. The lack of action is irresponsible and can affect many of us today and generations after us. Thank you for listening. I appreciate your time. These are my sources. I will now open up for questions. Thank you.